Hey, what's up? This is Paul Solt from Super Easy Apps, and today I wanted to do a little video talking about embedded Swift. So I've been playing around with embedded Swift with the goal of animating a 16 by 16 LED matrix, and that's kind of the driving force for this. So this is sort of, as I have time, I kind of work on this. I wanted to show off some of it. I haven't spent a lot of time on this, but I made a little test app because in the beginning when I was starting with embedded Swift, it was really slow. The development cycle was super slow to sort of prototype things out. And I'm not exactly sure what animations are going to look good. So I needed an easier way to test out animations. And so that's where SwiftUI comes in. This is a little canvas grid using SwiftUI that allows me to try out some different animations, see how they look, and interact with the time to sort of see like how is the animation progressing over time and what does it look like. So that's what we can see on screen right here. I have this pixel grid. I did this initially for a code challenge that required some kind of flood fill algorithm. I don't remember which company. There's been so many, but I had to do the flood fill algorithm. I sort of went above and beyond on the project and submitted it. I didn't finish everything, so it was like a time duration. I didn't finish everything in time, but I knew I wanted to play with the canvas grid, so I mocked up what it would look like to use the canvas grid as well as just using normal SwiftUI views. And then I made it so that I could have like 256 by 256, which is much higher resolution. Well, normal SwiftUI views are definitely going to choke on that, and they did. But the canvas grid is really fast. And so that was super cool to play around with. So I repurposed some of that logic that I wrote for that code challenge so that I could test out my pixel grid because I knew I wanted to mess around with that a little bit. So this is super naive implementation of just something that I can sort of play with the algorithms. And all I'm doing is I'm creating an animation over time. So I have an app, and I probably should pull that up, called Artwork Evolution. It's not on the App Store right now. I've got a rendering bug I've got to fix, but it was on the App Store. I need to update it again. And this allowed me to create genetic art. So all of these images are based on mathematical expressions. You get random patterns, random colors. And actually, I got some really cool ones that I posted on my last App Store update, which I guess was iOS 7, which was shortly before I defended my master's project. And this was my master's project. So I've had this art in several art exhibits at different coffee shops. That's why you see some printed material. This is on aluminum. I've got some of this hanging up here at home, and some of it is still for sale. So if you are interested in some abstract artwork, I still have some of these panels for sale here. This one's probably one of my favorite ones, and I want to hang that up again. I just haven't. But this was really cool. I've got this one hanging up in my hallway right now. It's a 3-panel, 24 by, I think, 16-inch panels. And the art that I created in this is super fun. And what I know is that if I introduce a time parameter somewhere in these equations, then I can create these animations that you see on screen. So this is a very simple black and white, very basic animation that I'm playing with right now. But it's to sort of get an idea of what this is going to look like on a 16 by 16 LED matrix. So the matrix that I'm working with is very small, very limited in the amount of clarity that I can have. So I need to find shapes or patterns or interesting things that work well before I actually deploy it on the microcontroller and sort of control it from there. So that's kind of my exploration. This is also another one of my popular pieces right here. It's probably my highest selling piece. Everyone seemed to like that one. So that is the app that sort of inspired this idea. I've got this whole concept of a grid, and then in the grid, I am creating colors at points. So that's all this is, and it's just a math equation. So the equation that you're seeing right now is a very simple equation. It's the absolute value of the sine of the x multiplied by the y multiplied by the time parameter. And just doing that, you get some crazy colors, crazy patterns, and you can get this animation if the time step is small enough between these different offsets. And so that's kind of what you're seeing here. One of the concerns that I have is on these microcontrollers, they usually don't have great floating point performance, but if I'm only doing a 16 by 16 grid, it might be enough. Some of the equations that I have are beefy to get some of those really pretty colorful images. And so I don't know if I'm going to be limited on the compute performance. And if that's the case, I might have to render out these animations or something and then play them back rather than calculate them on the fly. But so far, I've been able to get good performance with these simple equations that you see on this screen. I've tried these different ones, messed around with them, just made up some more complex ones. And so they work pretty well. So that's kind of my LED project, and that is just one of the things that I'm working on. And we can see that I think I have the demo. So like this is the demo of it running on here, and we don't need to listen to me talk here. But and I think this one's artifacting. It shouldn't look like this. So this is one of the other things I have to figure out. The animations that I'm getting here are different from the animations I'm getting on the LED display. And I think it's a coordinate system transform issue or something, but it produced some interesting results. It was doing different things. And this is not the same equation that you see here. I had something else in the embedded Swift project when I was playing around with that. So the turnaround time with the embedded Swift is a little bit challenging, and that's why I'm playing around with mocking up the animations that I actually want to run on the LED display in a xcode environment, because it's a lot easier to prototype, play around with some of these parameters, and sort of see what that looks like. So that's what I'm going to be working on sometime in the near future. I've got my coffee app that I'm still trying to get out the door. I'm trying to finish up the in-app purchases. I don't know what it is about in-app purchases, but they're complicated, and I've been testing like some of the error cases, and it's not working. So I need to figure out what's going on there. And then I've been working on interviewing, and I'm going to have another video about my job search update. I'm still looking for a job. And I'll talk more about those details in my next video. All right. So thanks for watching. If you want to learn more about embedded Swift, I've got a whole lineup of videos. I think I can show you here. So I've got probably the best two to start with are going to be my beginner's guide, which I think is pretty good. And then I've got sort of the overview of how my setup is working. I haven't gone over like how to actually configure this LED matrix, and I might need to show you how to solder that or how to work with that. So let me know in the comments down below if you're interested in that. And then I have one back here, which was the getting started and the troubleshooting. So I've got a whole playlist of videos. So if you want to learn more about embedded Swift, I've got a playlist called Explore Embedded Swift, and that's got all of my LED explorations. So that's got, this one's pretty popular. It's got a lot of views. That's my embedded Swift tutorial, which is just going over Apple's install guide. I've learned a bunch of different things along the way. So I have a troubleshooting video, and then I've got, there's a random integer crashes. So you can't use random ints on the ESP3266C, which is the microcontroller that I've been running. So this is one of them that was crashing. So I've got a workaround for that, which essentially is using the master branch of the IDF, ESP IDF build tool chain. Otherwise, you need a patch, and you need to apply that. So I got a whole video on that and blog post. And then I've got a beginner's guide, and then a project overview, like how is your project actually structured? So those are the videos I have. That's just because I want to share sort of how that works. Hopefully that's helpful if you want to explore this space. And that's all I have for this video. So in the next video, I'm going to be talking about my job search. I've been looking for iOS jobs. So if you're interested in that, stick around for that. Hit the like button and subscribe, and I'll see you in the next video.